Great. So yesterday, chalo chalo, get back. New student, no, no, no. Get back. ये मतलब take out your book. You're supposed to take out your books, not just sit in the class like that. So one topic is over, right, for your studies. One down you are right now, and many more to go. So yesterday I gave you some laws. NCRT is not having law of reciprocal proportion that I taught you, but NCRT has given Gay-Lussac's law. So I finish that first so that you know nothing remains from that chapter. So let us first finish Gay-Lussac's law of combining volumes. Now this law that I am going to teach you now is responsible for Avogadro's law, which is already taught to you. So everybody recollect Avogadro's law that we did in mole concept for gases. What was the law? If the volume is equal and the pressure and temperature is maintained constant, equal volume of gases contains equal number of molecules, right? Now that law came because of this law which I am teaching you now. Whatever. Okay. Oh my God. So many things to edit. So obviously this is the name of the scientist. So this is, now there are many laws with this name. I will teach you one more law given by the same scientist in gaseous state. So that is something else. That is the pressure temperature law. So this law is for combining volumes. I'll make you write the statement. I'll explain you the law. And we will do a problem based on this and we go ahead. So take down the statement for this law. Let us make this quickly, as we have to start with a new chapter today, right? So take the statement of the law. When gases reacts, when the gases reacts, they do so when the gases reacts, they do so in volumes that bears a simple whole number ratio. They do so in volumes that bear a simple whole number ratio to one another and to the volumes of the products, provided all volumes are measured at same temperature and pressure. All volumes are measured at same temperature and pressure. So I will explain you this law. Pay attention. So this law is applicable first only for gases. First is that. Second, only when pressure and temperature are constant. So these two conditions are similar to Avogadro's law. Now third condition here is the gases should react with each other. So this is talking about a reaction where gases are reacting, giving us a gaseous product. So understood the third condition? Okay, we need a gas as a reactant and we need a gas as a product. So I am explaining you this law with the help of a very simple example. See on the board. So I am having a hydrogen gas and that is reacting with oxygen gas and it is forming water vapors. Okay, now in this I need to balance this equation. So how am I going to balance? Obviously 2H2 and this will give me 2H2O. Is it clear? Why water is gas? Because it is at that temperature we are doing the reaction, as simple as that. So this is a gaseous reaction. Now what this law says? This law says कि whatever are the stoichiometric coefficients, you know that is a mole ratio. Now see, after mole concept it becomes very easy to understand. So everybody in the class understand that my reactants are in the ratio 2:1 and with the product it is 2:1:2. Nobody has any doubt understanding this, and this is your mole ratio. Now with the Avogadro's law we have connected to volume. Okay, so at same pressure and temperature, okay, if I am measuring their volumes will also have this ratio, yes or no? Because if I want to find what is the volume of 2 mole of gas, what I'll do? 2 into 22.4, 1 into 22.4 and again 2 into 22.4, yes or no? Are you understanding what I am talking? So if I want their volumes, what will be the volume of 2 mole of a gas? 2 into 22.4 liters, yes or no? Are you understanding what I am talking? So this will be 2 into 22.4 is to 22.4 is to 2 into 22.4. So what is the volume ratio? Again same 2:1:2. Are you convinced? So this we are doing after learning mole concept, yes or no? It's very easy for us. But this scientist told us before mole concept. Okay, rather this scientist, because he told about this law, Avogadro's law was developed and we could apply it to mole. So it is reverse actually. But to make you understand, I started with mole concept because it is easy. So what this scientist did, now go through the statement. See what he said. So volumes of the reactant and product will bear a simple whole number ratio. Did you understood that? And that ratio is nothing but, how do we know that ratio? That ratio is nothing but as per their stoichiometric coefficients. Are you understanding? So when Gay-Lussac said mole concept was not developed, Avogadro's law was not there, he gave this law first. So looking at this equation, what did he say? He says that, okay, for this reaction, 2 volume. So 2 volume of hydrogen gas we need because mole was not designed then. So 2 volume of hydrogen gas will react with 1 volume of oxygen gas and that will give 2 volume of water. So he defined this way. And if the pressure and temperature is same, okay, this 2 volume can be maybe 200 ml at STP, this is 100 ml at STP, then this has to be 200 ml at STP. Is this clear? And anything which will have a ratio 2:1:2. So this was the law given by Avogadro. He said that 2 reacting gases, okay, at same pressure and temperature will have a ratio of simple whole numbers of their volumes with each other and also with the product. Is this clear to you? So because he gave this law, Avogadro connected when the volume is same, Okay, number of molecules has to be same. Are you understanding now? Because when the volume is same, number of molecules are same, the reaction can happen. Okay, see when I am taking 200 and 100, that 200 is assuring me that whatever are the number of molecules of O2, double are there in H2. Yes or no? So when the volume is doubled, number of molecules are also getting double, because ultimately the reaction is at molecular level. I need 2H for 1O. So when I am taking double volume, this is guaranteeing me that number of atoms are also double. And that is how Avogadro gave his law, that equal volumes of gases will have equal number of molecules. And then from there we defined it as mole. So it all started with this law called as Gay-Lussac's law. And the importance is that he gave it before everybody. He was the one who could understand that if we are having gases, and if we equate their volumes, okay, they will bear a simple ratio. He didn't connect it to number of molecules. That job was done by Avogadro. Is it clear, everybody? Okay, now one simple problem based on this, and that's it. We start with atomic structure. Okay, and that doesn't mean this needs to be 200, 100 and 200. It can be any multiple of this ratio. It can be 400, then this becomes 200, that becomes 400. So any two given third can be calculated by using Gay-Lussac's law. This simple it is. You can equate the volumes directly with the number of moles. Am I clear? And then no need of STP here. He is not using any STP. He is just saying that pressure and volume are maintained constant. Equal volume of reactants, whatever they will have a simple whole number ratio. How you understand the ratio? See the stoichiometric coefficient. Today we know that there are stoichiometric coefficient. Clear this is? So see, solve this one simple problem and we go with atomic structure. No talking there. Somebody wants to talk, come here and give the lecture. Come. Continue ahead. So one first chapter is getting over. I already gave you some instructions yesterday. Today's instructions are all those whose name is NCERT, JEE Mains. Okay, so for JEE Mains student, please read the chapter like school from NCERT, properly mark important things in the NCERT textbook, solve in-text questions, solve the questions at the end of the chapter. You will be able to solve, but you do that. That's needed, okay, for you to get ready for JEE Mains. Problem part we are doing only. Okay? And finish this up now only. When I have just done the chapter. After 2 months you're going to forget everything and then it is difficult. Okay, don't have a time gap. Don't keep a backlog for anything. Try to finish it up fast with the class. क्या करना है? What you have to do? Just write a balanced reaction and finish it up the problem. No need of any mole concept, any conversion, anything. Nothing. Very simple problem on the board. So everybody can write the reaction. This is simply hydrogen gas reacting with chlorine gas and giving you HCl gas. So as per Gay-Lussac's law, it will be 1 volume of H2 is going to react with 1 volume of Cl2, and you are going to have 2 volume of HCl. As simple as this. Now see what is given. The problem says 50 ml of H2 is burned with 50 ml of Cl2. So data given to you is, and you don't need anything for these problems. This is 50, this is 50. So 1 volume is 50. Then how much will be 2 volume? Answer is 100 ml. That's it. Nothing you have to do. Just take a volume ratio and that's it. That's the answer. Did you got this? Everybody in the class? Very simple, right? Very, very simple. But I just wanted to connect that dot. Included now in NCERT and one law is removed. So let me be extra in doing, I don't want to miss anything from NCERT. NCERT keeps editing. NCERT editing means they are deleting only. They are not adding anything. So chapters are getting deleted and all, but we will do everything here. Yeah, reciprocal proportion is deleted this year from NCERT textbook, but we know. See, what happens is, even if they delete a complete chapter, I will be teaching you that as IIT Advanced doesn't delete. Understand this. If NCERT is deleting mains and NEET, it gets deleted. But if you are giving advanced, if you are giving other entrances like BITS, VIT, then their portion, we don't know, it may have, it may not have. Now all these syllabuses and portion we will come to know when you will fill the form. So we can't take a risk, we cover everything that is needed, whether NCERT is keeping or deleting. I will cover. Because every person gives multiple exams, no? So it has to be covered for all the exams. That's the aim. Chalo, we start with a new chapter now. I'm going ahead. And new chapter is new chapter is structure of atom. And see now first chapter over, new chapter is starting. I want everybody to improve from what you were in the first chapter. So I've really seen many shabby notes of so many students. I don't want that to happen now. See to it that at least you are sitting in the class, you're taking down the content from the board properly in the book, at least this much. Whether you understand or don't understand, that comes later. And believe me, if you just copy the notes, in that process itself, you understand so much. It's on, see, it's on. Let's see. Okay, so I was talking about taking down from the board. Understand? When you take down from the board everything, believe me, you need some focusing, and that much is enough for you to understand the content. All those students who didn't understood something, as a teacher when I see their books, Their books are shaky at that point. They haven't written, or they are scribbling, or they are doing something else. So, if you're not focused, you're not going to understand. This is basic. What is the basic thing that you should be doing to be focused? Just see on the board and write what I'm doing on the board. That's it. At least this much you can do, everybody in the class. You're here for that only, no? And in that process, you will understand. Tell me one thing. So your batch started on 4th May, right? And my first lecture was on 5th May with you. Today is 21st May. We have come ahead 15 days. Do you see any improvement in yourself? I never level down. I said I won't level down. I will at least maintain some level. You were struggling on day 1, day 2, day 3. Day 15, are you better or not? You feel what you were and now what you can solve. If individually in 15 days this difference has happened, believe me, we continue doing that. This difference will be, mark my words, this difference will be 3 times in next 15 days. You will improve 3 times in next 15 days if you put in now. Getting it? And from mole concept, I haven't done difficult problems, believe me. I will be giving you worksheets, I will be doing crucial mixing problems after some time, because I want you to be better, okay, able to handle. Okay, so I did all the basic, all your books, you take up a book and JEE mains level problems will be through. Can you at this stage solve a very difficult level problem of advanced? Answer is no. And no point me wasting time on that, because anyway it will be tough on you. So on down the line, I will do one lecture and I'll finish that up. And we all will do it very happily then. Getting it? So we have to be focused. Let it be difficult. You will achieve. Okay, everybody in this class is going to make it. For a simple reason, all of you are above average. Only difference, only difficulty is because the way it was in school, teaching and evaluation, and the way it is here, there is a difference. And some time goes. Is that clear? Okay, there are some students who are giving Olympiads and attending foundation right from 7th, 8th standard. They are already oriented for all this. So they are good. Or they are able to cope up. And if you belong to that who never did anything of that sort, you are in a school and first time you are seeing this, this is bound to happen. It's a very natural thing. So I'm not grading anybody at this stage. Believe me, whatever are your marks of your test, I'm not grading you on the basis of marks. What I want is, from your last test to this test, I want to see an improvement. And that's it. I won't mind you had a 30 marks in last test and this test today you get 40. I'm happy. And even you should be happy. So there has to be an improvement seen. And one day you will be doing better. And you continue doing this. Next 15 days, we'll talk in first week of June. Next 15 days will be remarkable. By that time this chapter also will be over. Getting it? Right? So we start with structure of atom. Now I'll just give you some idea what are we doing in this chapter. So this chapter is all the historical developments, theories after theories, experiments after experiments that scientists did, okay, to understand structure of atom. So it starts 400 years BC. A Greek philosopher said atomos for the first time. But in India, we are having Maharishi Kannan, who told us 2000 years before BC. And he said that material or any matter has something called as Parmanu. So, I mean, Western philosophy talk about the Greek philosopher, but Indian mythology, we always had Maharishi Kannan, who spoke about Parmanu much before them. And then after that, no development in this field. Then the first development happened with Dalton's atomic theory, which was given in 1808. So in the mole concept, I discussed that as a respect to Dalton. And I told you that what are the limitations of every postulate that Dalton is given. But Dalton's atomic theory was one of the major things that happened in the concept of structure of atom, in evaluating structure of atom. Then, there were series of scientists. Chemistry was not much happening then. There was lot of development in physics. Okay, there was a scientist called Michael Faraday. Have you heard of him? Faraday. Okay, so Faraday did lot of work in physics and in physical chemistry. In upcoming chapters, we are going to see Faraday's work also. But now the first experiment of this chapter that I am going to teach you is discovery of electron. And this experiment is done by Michael Faraday. Okay, the experiment which discovered electron. So here I'll be teaching now all the subatomic particles discovery. So till Dalton gave atomic theory, what was his postulate? First postulate says atom is something that is undivisible, right? After that, all these experiments started with the discovery of subatomic particle. Obviously, we know something that is present inside the nucleus and in the atom. And this is how, then after that, structures of atom theories will come. Where is neutron, where is electron, where is proton? Lot of scientists gave their own theories to place them. Okay, there were people who placed everything together. Then some experiments, and they came to know that proton and neutron are at the center, that is the nucleus, and in the extranuclear region there are electrons. So all this gradually we will see which scientist did which experiment, what is the conclusion. This way the chapter flows. Are you getting it? And yes, at the end I will teach you about the orbitals. I will teach you about the latest way to write electronic configuration. This is how the chapter will end. In this chapter, lot of things I need from physics. See, physical chemistry chapter, okay, is something in between physics and chemistry. There is an atomic structure taught to you in physics also. Okay, but their atomic structure will come at the end of the syllabus, and here in chemistry we teach in the beginning, because I need the orbital concept very clear. I need the electronic configuration part very clear. But there are some physics terms coming, so I will be explaining you some basic physics terms, Coulomb's law, okay, then forces of attraction, repulsion, magnetic forces, potential energy, kinetic energy, all that I will need in this chapter. So you will understand as I go ahead in this chapter, you will feel that it's almost physics that I am teaching. There is hardly any chemistry here. And there are a lot more chapters in physical chemistry which are this way. Am I clear? So because physics, some part of physics you have done it in school, some part of physics you will do at the end of your 12th physics. So I'll have to brush it up for you. I'll have to give the physics part little bit to you, and I'll continue with the chemistry part as well. So I've just given you a broad outline of what we are doing in this chapter. And I start with the first experiment, okay, that we are going to learn in this chapter, and that is discovery of electron. We are going to understand how electron is discovered. So this electron discovery, okay, was done by a scientist, J.J. Thomson, okay, followed by the experiments carried out by Michael Faraday. Okay, what Faraday did is he did experiments with water having some ionic compounds. Okay, electrolysis everybody has seen, right? So if there are ionic compounds in water and you put two electrodes, cathode and anode, what he could see is the positively charged ion will go to the negative electrode, and negatively charged ion will go to the positive electrode, something like this, right? Are you aware of electrolysis? So these kind of experiment Faraday was doing on the same line. Then J.J. Thomson did something with a gas, and that accidentally discovered electron. Okay, so discovery of electron, full credit, all credit goes to a scientist called J.J. Thomson. And this experiment is called cathode ray tube experiment. So before explaining you a CRT experiment, cathode ray tube experiment, I will show you first what is a cathode ray tube. Okay, how does this tube looks like? So a cathode ray tube is a glass tube. And you all will draw diagrams with me now. What you can't see? Blue color you can't see? Really? How come? How come? How come? Don't tell me. Don't tell me. I can see. Is it at my age if I can see? And then you say you can't see. Really? I'll change the color, that's okay. But I just wanted to, because this color is so popular. When you see on these kind of boards, videos on YouTube and all, this color is very popular. Everybody is using fluorescent colors. Yeah, everybody is using fluorescent colors, so I thought of using. And then my students are not liking, so I'm changing for you, no problem. So which color? Where is that? This one. So this is almost, chalo chalo, start drawing with me. So see what is cathode ray tube experiment. Is this color okay? This is like white only. So what I am drawing on the board is a glass tube. And if I can draw this with a stylus, you should be able to draw it. So this is a glass tube. Now see what all the things are there. There is one opening here to add a particular gas inside the tube. So first we will take a tube. Now when I take an empty tube and it has a opening, there will be air inside, everybody understands, so there will be some air inside. And we want to create a vacuum, or we want to create a low pressure, then from here we can connect it to vacuum and alter the pressure inside. And from here we can fill in a particular gas. I want the inert gas to be in, nitrogen to be in, of my choice. Okay, so we can remove air, we can add a gas, we can manage pressure from that outlet which I have shown. Everybody clear? Functions of that outlet. Now here, two metal plates, one on this end, and another one on this end. So what are these plates? They are your electrodes. Right now they are just metal plates, they will become electrodes when I will connect it to a external power supply battery. We will be doing lot about battery in 12th standard in electrochemistry. We will construct the battery in 12th standard in chemistry. So why you have to talk while copying it down? See, the two metal plates which were inserted are externally connected to a power supply or a battery, and the one which is connected to the negative end of the battery will become negative, one which is connected to the positive end of the battery will become positive. The negative electrode is called cathode and the positive electrode is called anode. Is it clear till here? So what is this? This is a power supply or a battery. And what is this? This is, we call it as key. What is the meaning of key? A button. So when I will press this, the flow will start. When it is not pressed, it is disconnected. Did you understood the simple flow here? No, this is, no, we show it this way only. So when you are doing an experiment, it will be a closed thing. So copy this and I'll explain you this experiment. So there is nothing called cathode and anode. Again, understand. They just inserted a metal plate. So the electrode story started with Faraday. That's what I say. Who started this? Metal rods and attaching it to battery thing? Faraday. So when you attach a battery to a metal rod or a power, electricity was discovered. After electricity is discovered, scientists started passing that electricity in solutions, in air, in gas, in everything. So this fellow passed in gas and Faraday passed it in liquids. That's the only difference. So there is nothing called cathode and anode. They were metal plates connected to the battery. Now why the name comes cathode? Where cation go, abode of cation is cathode and abode of anion is anode. That is how the name came. Where a cation go is cathode. So cation will move to a negative charge and anion will move to a positive charge. Is this clear? Is this nomenclature clear? Can I go ahead? Have you finished drawing? So this on the board is called CRT, cathode ray tube. Okay, which is a evacuated glass tube fitted with two electrodes and an external power supply. And then what did they do? They took out the air, no talking, second last bench and last bench. If I see you talking now, all of you are going out. I'll make you sit in 102. You prefer sitting in 102, right? So I'll make you sit in 102. And from there you attend the class. No problem. Or I'll make you sit down in the office. There also you can see it on a video. So you are attending a class but not in my class. Because you are disturbing me. As simple as that. Am I clear? Okay. So see here, we are removing the air. We are putting one particular gas now. Okay, say hydrogen or helium, whatever you want. One particular gas is filled. Now what they did is, they started experimenting. Okay, J.J. Thomson started experimenting. Initially, at normal pressure and normal voltage, so normal voltage is around 200 to 30 volts, nothing happened. Okay, nothing happened. He could not see anything happening inside this tube. Then he went on decreasing the pressure. Everybody understand? To decrease the pressure, here what I have to add? A vacuum pump. Have you seen a vacuum pump? Where you have seen a vacuum pump? Yes, inside a vacuum cleaner there is a vacuum pump, and in the labs there are actual vacuum pumps. Okay, which we use in chemistry lab also for filtration and other things, and for this kind of experiments where we have to apply pressure. So this was connected to vacuum pump. Now see ahead. Then what happened? He went on decreasing the pressure. When the pressure of this pump, now usually what is the pressure? 1 atmosphere, 1 atm, 1 atm, I gave you the conversions last lecture. 7, 76, how much? Check. In terms of mm of mercury, tell me the pressure. 760 mm of mercury is equal to 1 atmosphere. Now see the number that I write on the board and make me understand whether this is high pressure or low pressure. So 0.11 mm Hg, zero point 0.1 mm Hg. So what this pressure is? High or low? Very low pressure. See, 760 mm is 1 atmosphere. You decrease that, you make it 600, 500, 100, 1 and then 0.1. So there were series of experiments. Now I am telling you, when something happened, that pressure was 0.1 mm. So everybody in the class understands that this pressure is something extremely low pressure. So this is not ordinary pressure. This is not happening just like that at ordinary condition. The pressure is very low. Now focus here. This is your battery or power supply. So what is the power supply? How many voltage power supply we have right now? Which is making everything work? How much? 230 volts, right? Now see the voltage. So he started with normal volt. He went on increasing the voltage, and when the voltage was equals to this number, something happened. So this is high or low, tell me? Tremendously high. So the voltage across this plate was 10,000 volts at an extremely low pressure. These are the conditions required, okay, for the experiment that I am describing you. So when he applied this condition, what he could see, this was a transparent tube. What he could see inside the tube is something that we see when during the rain there is a lightning in the sky. Have you seen lightning in the sky, everybody? So what happens in the lightning? From one end, a light is, we can see a spark or a light traveling to something. It travels, right? Lightning always travels. So something like that, he saw traveling inside the tube, a light traveling, a sparks traveling. From which end to which end? From cathode to anode. Okay, so I'll show you what he saw. Okay, and I'll explain you the experiment, what has happened. But understand that not at ordinary conditions. So this is what he saw. So what I am showing you here with a red color pen is actually something like lightning, and traveling from cathode to anode. Okay, when he did this experiment at that time, okay, it was like science was not considered good and scientists were not considered good people at that time. Yes, there was a time when they were punished for the experiments that they did. That was the time. So when something like this, they showed it, they demonstrated this experiment publicly, and then the people at that time felt that they are gods because they could create a lightning. What a god creates, a scientist could create inside the tube. So after these kind of experiment publicly displayed, they started getting some respect. Okay, so this was the first experiment which was publicly displayed as lightning generated in a tube. Yes. Please Google and read the history of 18th century, 17th century, what happened to the scientists because they did some discoveries. That's, but that's not the topic that I want to discuss in the class. I just want to be restricted to scientific communication only. But yes, you can check this out. No, 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 no. No, I'm explaining. So this experiment, now I'm not talking about anything else. I'm talking about this experiment, and in this experiment, the movement is starting from cathode and it is going to anode only. I'll explain what it is, why it is, everything. Get back on the board. So he named, because he could see that the rays are starting from cathode, he named these rays as cathode rays. And this experiment, so undoubtedly it is starting from cathode, it is named as cathode rays, and this experiment is also known as cathode rays experiment. Okay, so this was the first experiment. Now what is the conclusion? Okay, the conclusion is that inside a gas, now see what is the whole thing? We were having a gas. Now what a gas will have? Atom, if we take helium gas. Helium gas is made up of atoms of helium. Ideally a atom should be neutral, right? That's what our idea was. So what should happen? Nothing should happen when we place an atom in the charge field. Nothing should happen. When things should happen? When something has a plus part and a negative part. Basic. Okay, if you are putting something which is neutral and two plates, will that neutral go towards positive plate or will that neutral go towards negative plate? So ideally why this experiment was done? Just to confirm that is atom neutral or there is some charge present in atom. Okay, this was the reason these kind of experiments were performed. Are you understanding the aim behind it? Okay, everybody understand if something neutral is put in, nothing should happen. And initially at low pressure and low temperature, nothing happened. So if there is a helium gas, nothing should happen as helium atom is electrically neutral. So what does this prove? Tell me. So this proves that, the atom has something inside it which has charge. First point, something inside it which has charge, and which charge? Negative charge. As the flow is towards positive. Okay, it is negative, that's the reason it is flowing towards what? Positive. So, J.J. Thomson experiment, we never got the name electron here. Okay, though I am writing discovery of electron, when he did the experiment, he just said that, okay, this tells that there is something present inside the atom which has negative charge and which is traveling, because it is traveling towards positive charge, and he just named it as cathode rays. So actually this experiment discovered cathode rays. But later, after series of experiment which I am going to teach you, he discovered and he named it as electron. So this experiment, we are still with the name cathode rays. Okay, that is called as electron came much later. Am I clear with this? Now see, so he discovered cathode rays and named it as cathode rays because starting from cathode going to anode. Now he did some more experiments on the same CRT, this cathode ray tube. Now I'll tell you what this cathode ray tube is. Okay, eventually you will understand what I am talking. Now I am discussing all the experiments done by J.J. Thomson to understand properties of cathode rays. So he discovered cathode rays. What is the next job he did? He started understanding properties of cathode rays by doing some more experiment inside CRT. So we are discussing all that one by one, and I am discussing every experiment done by him. So he discovered something called as cathode rays. And then he wanted to know the properties of cathode rays, right? Now see what all the experiments he did and what he did to understand these experiments. He modified this tube. Okay, to understand some readings, he modified this tube. So see, when he did the experiment, though he was knowing that the rays are traveling from negatively charged electrode to positively charged electrode. It was lit. Okay, and when it is lit, it is very difficult to understand. You know what this tube is? This tube is tube light. This tube is today's tube light. Our tube light is CRT, and it is lit. Okay, but we can do, the technology went ahead, and now we can do at a normal voltage and with the pressure that is built inside. So our tube light is this. So now when it is a tube light, can you see something moving from this end to that end? So similarly, that it was confusing for him to understand whether actually some experiments were showing that it is moving, some totally got lit and so on. So he confirmed further by modifying this a little. Even your old televisions, not this LCD and LED, if you have seen the old televisions which had this kind of a big back, have you seen that? I'll explain you that now. The next thing that I'm going to draw is that television only, but shown to you in a different manner. So that television was also a cathode ray tube. Bolo. No, that technology is very different. That's a different technology. The old times tube lights and old times TV I'm talking about, they were of this kind. Okay. So I'm modifying this diagram. See what modification I'm doing. So all this part is remaining same. And now here I'm attaching something called as a screen. Or I will draw a diagram once again. I'm going to next page and I'm explaining you properties on next page because editing that diagram looks difficult. So I'm little bit modifying this CRT for you. So some extra light coming from behind. Somebody started that light or it was already on? This? You can see, no, there is nothing shiny on the board, right? So start copying it down with me. So you see one addition here. So this is your basic CRT. Now see what we are doing. In CRT, they have taken an anode which is perforated. So to understand the properties of cathode rays which were starting from cathode and hitting anode, to study the properties, he wanted it to pass through anode and come on the screen. So what is put here is a screen. This is a screen. Coated with a material ZNS. Now this is that old TV. The old TV's screen is this and this is that behind part. And there when some what you can say, when some picture is not coming, dot comes. So those dots are electron coming and hitting on the screen. These screens, okay, are special kind of screens which can detect radiations, okay, fluorescently. Means if a electron is coming or any particle is coming and hitting the screen, you will feel a light or like a star. So the whole purpose of this screen is first to prove that whatever these cathode rays were there, they were starting from cathode, traveling to anode in this direction only, right? And here they place some more electric field and magnetic field to confirm that. So yes, I am showing cathode rays and I will modify these as I go ahead. In the next experiment, I am going to modify the same tube. So I am showing you cathode rays now. Okay, they will pass through this. So all this I am doing to teach you some experiments, and we will simultaneously discuss properties of cathode rays. Simultaneously discussing properties of cathode rays. So what is the first property this experiment would tell us? When they applied the required voltage and required pressure, okay, the rays were starting passing through this perforation, and they could see that it is hitting the plate here. So what is the first conclusion? You simultaneously write down the properties, also give the heading properties. I will explain each property and I'll make you write simultaneously. So you will go on modifying the diagram and you will also line. Cathode rays travel in straight line. This is the first experiment. Clear? First property. Then what they did is they placed two electric plates. So I am placing two electric plates. So what is the whole meaning of electric plates? Now another battery connected to another battery. This is positive, this is negative. So whatever were the rays coming, okay, they were subjected to electric field. They wanted to understand how these particles, how these cathode rays are going to behave when they are in an electric field. So what happened, see on the board, I am explaining their behavior. So till here they were straight. Then they started deflecting and they were hitting. Initially they were straight, but now they were seen hitting this side and not this side. Getting it? So this experiment clearly proves that they are negatively charged particles as they are deflected towards positively charged plate. Am I clear? Right, so this multiple experiments I am showing you by editing the same diagram. You won't be able to edit the same diagram. I can. Okay. It's not light, it's particles. It's not light. I'm not talking about a UV radiation light here. I'm talking about some cathode rays. And I'm discussing properties of cathode rays, though they are shining right now at these conditions. Okay, so it's not light property I'm discussing properties of cathode rays. Because they have kinetic energy. I will explain you as we go ahead. See, somebody, I'll tell you, somebody who has energy, then if something comes in between, It all depends how much energy is there to pass through and go. Getting it? So if energy is less, it will stay. But they have tremendous energy. We will start calculating all this next lecture. So there is tremendous kinetic energy. So they will pass through. And when they will hit the screen, then only like they have to stay because there is no place to go. Something kind of this. Okay, so perforated anode, they come out. Okay, and they go and hit this side. So what is the conclusion? Second conclusion, right? These radiations are these radiations are negatively charged. These radiations are negatively charged as they are deflected towards positively charged plate. Yes, as they are deflected towards positively charged plate. So is the second conclusion clear to you? Okay, now their energy, I'll prove now. Next experiment, I'm going to prove that about something about their momentum. I'm showing you an experiment. Now everybody has seen a small pinwheel. क्या बोल सकते हैं pinwheel को? Uh, when you are small, that no, not the giant whale. With the balloon, the balloon vendor sells that, no, small pinwheels. What is that called? I can't pronounce that. Okay, I'm trying to draw a smaller version here. Round, round. So what they did is, they placed the pinwheel inside. I'm drawing so everybody will understand what I'm talking about. A pinwheel is, we use the word pin because it is having a pin. So see a small pinwheel I'm putting here. And understand what is a pinwheel. So pinwheel is a wheel which is attached to a pin, and if you place it say in the wind, it will rotate. A small wooden pinwheel comes. You might have played with it as a kid. So there is a pinwheel and they placed it inside. Now see, ideally if you take that pinwheel and in the house you place it inside a glass cupboard, is it going to rotate? Tell me. So what is required for a pinwheel to rotate? Some force. Some force. Which wind is giving? Yes or no? So when they placed it inside this cathode ray tube, what is expected? It should stay like how it stays inside a glass cupboard. But what happened? It started moving. Inside this tube, a pinwheel started moving. What is the conclusion? Whatever are these cathode rays, so see the cathode rays are coming. So who is giving them that momentum to rotate? A cathode ray. So cathode ray is a particle which has momentum. Third conclusion, because it has momentum, it can make a pinwheel rotate. It has an energy associated with it. So when it is hitting that pinwheel, inside, even if it is an evacuated tube, pinwheel is rotating and in this direction only. Again tells they're coming from that end and rotating, kind of a thing. Is it clear? So third conclusion, take it down. They consist of particles having momentum. They consist of particles having momentum which they are transferring which they are transferring on a light wheel. They consist of particles having momentum or which is getting transferred on a light pinwheel. Can I explain you the next experiment? I am editing this. Which is getting transferred on a light pinwheel and are responsible for rotating a light pinwheel. Now see, if very simple, I am showing you an experiment, I am telling you a conclusion, and I expect after this kind of lectures, you should be able to write your own notes. Why you want me to dictate? If you have understood, right? Did you understood? You should write on your own. That is when the focusing will come. Otherwise, what you said, and because you are talking, you don't know what I said. Isn't it? So what is the moral of the story? Particles, cathode rays are some particles which have momentum, and when they hit the pinwheel, the momentum is getting transferred, and that is what is making the pinwheel rotate. Can you write this on your own? Please do it. So you understand also and you write also, and it is done in the class. Am I clear? So it's not a school that word to word I have to dictate. No need. Now what I am going to do is I am going to make them pass through a magnetic field. So drawing that is difficult, still I'll draw, but I'll first explain you. So this is my CRT right now. Can everybody understand? It is something like this only, right? And there is a screen here. And right now I have placed one plate here and one plate here, electric field. So electric field is placed this way. Is everybody understanding placement of electric field? Now see carefully, I am showing you how a magnetic field is placed, okay, on this CRT. Now magnetic field we have to place perpendicular to electric field, and this has a meaning. I'll explain you the physics part from next lecture. I'll give some basic physics and I'll make you understand what is magnetic field, what happens to a charged particle and all that. But for this experiment, you can understand what I'm talking. So electric plates are here and here. And now see, everybody has seen horseshoe-shaped magnet. Okay, so that is here, like this, like this. So it's a U-shaped magnet. So the north pole is here, then it is coming down like this, and the south pole is here, this way. Can you understand? Like a half ring. Getting it? So two poles of the magnet are here, and the field electric is here and here. So are you understanding? The magnetic field is this way, and the electric field is this way, placed perpendicular to each other. Am I clear with this? Now see, when I try to draw a 3D in 2D, it always confuses a student. I'll draw it, no problem, but I'm explaining you how it is, even if with the diagram you are unable to see. So this is your CRT, this is the plate, okay, this is electric field here, and this way is the magnetic field. So this way and this way is perpendicular, okay, and that U-shaped magnet, everybody has seen, right? Horseshoe-shaped magnet. So it's like a half circle or a U. In English alphabet U, something like this, like this. Okay, so like this. Are you getting it? Okay, this way we will place a magnetic field. Now see what happens when I place a magnetic field like that. Okay, so there is an electric field also and there is a magnetic field also. We are placing both. Right? When there is an electric field, we saw particles going straight because they were only under the influence of what? Electric field. But when we started applying magnetic field, something else will also happen to them, isn't it? There will be some effect of magnetic field on them, and we went on increasing the magnetic field strength till that magnetic field will pull down the particle and it will move straight. That is what is compensating electric field and magnetic field with each other. The electric was pulling towards positive plate. Now we applied magnetic field and we changed the direction by increasing the strength of magnetic field, and then we will have a magnetic field and electric field balancing each other, and we will make the particle go straight. And at this stage some experiments are performed, okay, and based on that some conclusions are drawn. Am I clear about it? So I'll make you write all this. First I'll make you write, then I'll draw everything after that. So next point, these radiations are deflected. These radiations are deflected in external magnetic field. These radiations are deflected in external magnetic field and by measuring so to put a magnetic field, you know what I have to do now is I will have to remove electric field, otherwise it will add to confusion. So I am removing this electric. So for some experiments we are simultaneously using the both. For some experiments we are only using electric. Okay, I'll tell you when both are there, when only magnet is there. So right now no electric, only magnet. See what happens. So this, how much we wrote? These radiations are deflected in external magnetic field by measuring radius of curvature of deflection. By measuring radius of curvature of deflection, charge by mass ratio. By measuring radius, I am explaining you this part. By measuring radius of curvature of deflection, charge by mass ratio, into bracket write, this we will keep calling it as E by M ratio. Charge by mass ratio, into bracket write, E by M ratio of cathode rays can be found out theoretically. Charge by mass ratio, that is E by M ratio of cathode rays, can be found out theoretically. So for this I do not need electric field, I am only placing magnetic field. So when we place a magnetic field, see what is happening, I am trying to explain you. So everybody knows electron is a charged particle, and charged particle when we place in external magnetic field, it will start rotating. And when it starts rotating in a circle, there is some radius of curvature, and from that these kind of observations can be made. And I'll show you the magnet part and the deflection part, everything now. So I've explained you how this is in 2D, sorry, in 3D. Now I'm trying to draw this in 2D. So this is your magnet with one pole here and another pole here, and it's a horseshoe shaped magnet. Is it making some sense? Okay, one part is from another end, one part is from this end. Now when they are placed like this, see what happens. Now due to this magnetic field, they are deflected and they will go in a circle. And from this radius of curvature, E by M ratio is found out. Okay, now details of it, obviously magnetism is not taught to you in physics right now, lot more to come in physics. So just now just understand this much, charged particle subjected to magnetic field, they start rotating. This much is enough. Okay, and from that what is the conclusion? This conclusion is important right now to understand. We find E by M ratio. What is E by M ratio? Charge to mass ratio. Okay, this was detected for whatever was the gas, say helium taken. So he could find out charge to mass ratio. Now see, he was calling this as cathode rays. From cathode rays, how he reached to the conclusion that they are electrons? I am explaining. So once he was able to calculate E by M ratio, say for helium, then he performed the same experiment by changing the gas in the tube. Maybe helium has something like this. Then he took another gas, say nitrogen. He carried out the same experiment. He calculated E by M ratio. By then everybody was knowing that mass of helium and mass of nitrogen is different. So if something is different in nitrogen which is not there in helium, then this should change, right? Charge to mass ratio should change. And like this, he repeated this experiment many times by taking different gases who have different masses. And what is the observation? No matter which gas he takes, okay, no matter which gas he takes, the most important observation of this cathode ray tube is E by M ratio remains same for all gases. So this is the most important conclusion that he found out. What is the meaning? You take anything, okay, any matter inside that tube that has something common. So cathode ray is present in helium also, argon also, nitrogen also, oxygen also, anything taken in the cathode ray tube. Because charge to mass ratio is same, means whatever is that particle is same. And this is how, after confirming that E by M ratio is same, he said this is something present in all the atoms. Okay, it is there in helium also, oxygen also, nitrogen also, whatever gases were taken, and then he named it as electrons. So nomenclature happened after series of experiments, after confirming that E by M ratio is coming same. So I made you write up to a particular point, right? So what was that? From radius of curvature, E by M ratio of cathode rays can be found out. Continue writing. Theoretically, I just have 4 minutes, let me finish because next lecture is there. Theoretically, E by M ratio for cathode rays, theoretically, E by M ratio for cathode rays is found out to be, I am writing a value on the board, you copy that. Theoretically, E by M ratio for cathode rays is 1.76 into 10 raised to 11. Unit of charge is coulomb. Unit of mass is kg. So unit of E by M ratio is coulomb per kg. So this number was coming by doing calculations, by taking different gases. The number was with practically remaining same. So now after this the conclusion. found to be 1.76 into 10 raised to 11 coulomb per kg. Independent of the gas taken or the material of the cathode used. Independent of the gas taken or the material of the cathode used. So he not only changed the gas inside, but he thought, are they coming from this metal? So he took different metals and did the experiment. So every possible care was taken to understand it. And now we write the conclusion. Next point. As the E by M ratio was same, he concluded that as the E by M ratio was same, irrespective of the gas taken or the material of cathode, we can repeat this, as the E by M ratio was same, irrespective of the gas taken or the material of cathode, he concluded that these particles are present in all the atoms. These particles are present in all the atoms and named them as electrons. In all the atoms and named them as electrons. Okay, so that's it. We finish electron discovery. Tomorrow I'll start with proton and other stuff, and I will also do little physics. I want you to revise school ka Coulomb law and all those stuff. Right, you are done. So little bit of that part, please revise and come. I will do the revision in the class as well. That's it for today. Best of luck for your chemistry exam. Bolu. Of course, I was explaining different experiments. So when I made you write first thing, that was a experiment number 1. Then when I edited, that's experiment number 2. That is. There were thousands of experiments done. We are writing the conclusion. Yeah, this no. Next lecture, when I will show you the discovery of proton, in this only I will talk about that. That's the screen place. Nothing but a screen place. It's like a TV. I told you, old TV, a screen and CRT behind.